Alright, today we're going to be looking at this problem, which I found on Pinterest of all places. It's pretty straightforward. It's find the length of the square side, and you're given these three pieces of information. There are these lines that are drawn inside the square, and they have lengths of 12, 3, and 9, and you're supposed to find the length of the square side, which we'll call x. So when I first saw this problem, I was thinking, okay, so there's right angles in this problem. We might be able to drop something down like that, or like that, and solve for areas, and maybe add that up. Find the square root of the total area and call that x, but that really went nowhere, and it got really confusing really fast. My next idea was to draw lines parallel to what was already being drawn, but the problem with doing that is that it's really difficult. It gets really messy really quick because you don't know these angles, and I'm not saying you can't do it that way, but it involved a lot of trigonometry, and I found a much easier solution. And my final bad idea was to do coordinate geometry. So I tried setting this point as 0, 0, and then I was trying to find, hey, what could this point be in terms of 0, 0 on if we put this whole thing on a Cartesian coordinate plane. And this was a lot worse than my other ideas. You don't know this, you don't know any of the angles, so you can't do anything with slopes, and honestly there wasn't much you could do. So basically I wasted 30 minutes before I came to my final good idea. So all I did here was remove the sides of the square. We've still got this weird lightning bolt figure on the inside, but I've removed everything else, and I've removed all that noise. Then to make things more clear, I rotated the image, and that's what you get. So how does this help? Well, all we wanted was this. That was a diagonal of the square as seen in the original picture. If you don't believe me, there it is right in the original picture. So solving for this diagonal will help us find the side length of the square. So how do you find the length of that red line? I'm going to do everything in green from now on so it's less confusing. So we have this length. And we know that that forms a right triangle. This height is 3 as it matches up with that other height of 3. And we know that the length is equal to 12 plus 9, or 21. So now we just got a right triangle with a height of 3, a base of 10, and we need to find the red length, which is the hypotenuse. So that's easy. We just use the Pythagorean theorem. 3 squared plus 21 squared is equal to square root of 450, which is equal to 15 radical 2. So again, just to clarify, that value 15 radical 2 is equal to the length of that red line. Alright, so going back to our original problem, that red line is back there again, and we know that that is equal to 15 radical 2. So if this value is 15 radical 2, we know that this side is 15 and this side is 15 because it's an isosceles right triangle, and our answer is 15.